So, we've all been there. You write some code, hit save, and boom, it shows up in the browser. But what really happens in between? How does a simple text file, just a bunch of characters, turn into a fully interactive web page? Well, in this explainer, we're going to map out that exact journey, from the raw code all the way to the final pixels you see on your screen. Think about it. You write a simple HTML tag, save the file, and suddenly, pixels appear on a screen. But how? I mean, that text file has no real power on its own, right? It can't control memory or talk to the processor. So what's the magic trick that gives it the ability to create these rich, visual experiences we use every day? Let's break it down.
Okay, so to really get a grip on what's happening under the hood, we first need to kind of reframe how we see the browser itself. It's not just some simple window for looking at pages. It's an incredibly complex and powerful piece of software. Seriously, you should think of a modern browser as its own mini operating system. It has its own networking stack to handle requests, its own data storage systems like cookies and local storage. It's got timers for things like set timeout, and of course, a super sophisticated engine just for rendering visuals. Once you start seeing it that way, the magic starts to make a whole lot more sense. And you know, this powerful tool didn't just appear out of nowhere. The journey started way back in 1990 with text-only interfaces. The real game changer was Mosaic in '93, which was the first to show images right alongside text. Then came the browser wars of the '90s, and later, the arrival of Google Chrome in 2008, which really pushed innovation on speed and simplicity. All of that led to the sophisticated apps we're using today. All right, so you type a URL into the address bar and hit enter. What's the very first thing that happens? Well, before a single line of your code is even looked at, a pretty complex networking dance has to take place. Let's place this first step on our roadmap, the journey to your screen. First up, the browser has to do a DNS lookup. This is basically like looking up a name in the internet's phone book to find the server's real IP address. Once it has that, it establishes a stable connection with something called a TCP handshake. Then, for a secure site, HTTPS, a TLS negotiation follows, creating a nice encrypted channel. It's only after all that is done that the browser finally sends the HTTP request asking for the web page's content. And get this, each one of those steps is a round trip to the server, and all that time adds up, contributing to the initial load time. So once that connection is finally made, the server responds, and the very first chunk of data it sends back is typically around 14 kilobytes. Now, that's not just some random number. It's actually a sweet spot determined by TCP protocols to get the initial content to the browser as fast as possible. This is the first little piece of the puzzle the browser gets to start working with. Okay, so the browser has that first chunk of data. Now its real work can begin. It needs to take that raw text and turn it into a structured blueprint that it can actually understand and use to, build a page. And this process is super methodical. It starts with the browser receiving raw bytes, just zeros and ones. It converts these into characters we can read. Then, something called tokenization happens, which identifies all the building blocks, like your H1 or div tags. These tokens then become objects, which we call nodes. And finally, these nodes are all linked together in a parent-child structure, creating what we know as the Document Object Model, or DOM. You can think of this DOM tree as the browser's internal map of your HTML. Now, at the same time, the browser is doing the exact same thing for your CSS. It takes the raw CSS file and runs it through a similar process, bytes, characters, tokens, nodes, to create another tree structure. This one is called the CSS Object Model, or CSSOM. And this tree, as you'd guess, represents all of the styles. So for now, we've got these two completely separate blueprints, the DOM for content and the CSSOM for style. But while the main thread is busy building that DOM, the browser has this clever little helper called the Preload Scanner. It's like a secondary parser that scans ahead in the HTML, looking for high-priority stuff like style sheets, scripts, or fonts. It then starts downloading them in the background, so by the time the main parser actually needs them, they're already on their way or fully downloaded. It's a fantastic optimization that really helps reduce those annoying bottlenecks.
So we've got our two blueprints, the DOM for our content and the CSSOM for our styles. Now it's finally time to put them together and actually draw something on the screen. This whole stage is known as the critical rendering path. This process unfolds in 4 key steps. First, in the style phase, the browser combines the DOM and CSSOM to create something called the render tree. Now, this tree only includes elements that will actually be displayed on the page. Next up is layout. This is where the browser calculates the exact size and position of every single element. After that comes paint, where the browser literally fills in the pixels, drawing the text, the colors, the images onto different layers. And finally, the composite step assembles all these layers in the correct order to display the final page you see.
Now, understanding this whole process isn't just some academic exercise. It has direct, practical implications for how we write our code. So think of this as a crucial checkpoint on your developer journey.
We've covered HTML and CSS, but we've left out a major player here. So what about JavaScript? Where does it fit into this picture? And why is it so often the culprit behind performance issues? Okay, here is the absolutely crucial point. When the browser is building the DOM and it stumbles upon a standard script tag, it stops everything. It literally pauses parsing the HTML to go download, parse, and execute that JavaScript file. And what does that mean for the user? Well, often it means a blank wait screen. The browser has to do this because JavaScript has the power to change the DOM, so it has to wait and see what the script is going to do before it can move on. And here's something that surprises a lot of developers. It's not just the HTML that JavaScript can block. JavaScript execution will also be halted if the CSSOM isn't ready yet. And you might be asking, why? Well, it's because your script might need to ask for an element's style, like its color or its size. If the CSSOM isn't fully built, the browser can't answer that question. So yeah, this means that your slow-loading CSS can actually block your JavaScript from running. Crazy, right? And this is why understanding script loading strategies is so important. By using the async or defer attributes on your script tag, you're basically telling the browser, hey, go ahead and download this file in the background, but keep building the DOM. This simple change prevents the script from blocking that initial render, which can dramatically improve the perceived performance and get content in front of your users way faster. All right, so let's wrap this up with the key performance takeaways. First, defer any non-critical JavaScript with async or defer to stop it from blocking the parser. Second, make sure your CSS is small and delivered quickly so it doesn't block rendering or your JavaScript. Third, keep your HTML clean to minimize the number of DOM nodes, which speeds up those style and layout steps. And finally, always declare your image dimensions in your HTML or CSS. This prevents the page from jumping around, which forces the browser to do that expensive layout step all over again. So you see, every single choice we make as developers, how we structure our HTML, how we load our CSS, or how we execute our JavaScript, it all directly impacts this incredibly intricate journey. Now that you know the path, the real question is, how will you optimize the journey for your users? I really hope this explainer helped clarify the incredible amount of work a browser does behind the scenes. By understanding this path, you can build better, faster experiences for everyone who uses your sites. This is Developer Roadmaps. Map your path, build your career.